Learning Outcome 2, Algebra and Equations, 11.2.5a. Solve quadratic equations by factorization, by computing the squares, and by using the quadratic formula.
Hi, Teboho. What are you doing here so late?
I was waiting for my transport, so I thought I'd take some time to do homework.
Great idea. But it looks like you're struggling a bit. What are you busy with?
Well, my teacher says it's revision, but I honestly can't remember doing any of the stuff.
Well, I've got some time. Why don't you come into my class? Maybe I can help you.
Thank you so much. I could really do with the help.
By the end of the lesson, you should be able to solve quadratic equations by factorization. Well, let's have a look at what you are busy with. It looks like you're busy with quadratic equations. You would have covered this work in grade 10 and grade 11.
If only I could remember it.
Well, let's see if we can jog your memory then. We can start with this first question on your worksheet. What can you tell me about this problem?
Well, I know it's an equation and that we need to find the value of x. The problem is that there's an x squared here and an x here. How do we get x on its own so that we can find its value like we do with the other equations?
This is a special kind of equation. We call it a quadratic equation. In this case, we need to use a different method to solve for the unknown.
How do you know it's a quadratic equation?
Well, you just need to know what characteristics to look for. Firstly, quadratic equations always have three terms, and the equation is in the form of ax squared plus or minus bx plus or minus c when equal to 0. In this example, we can clearly see that there are three terms. This x is to the power of 2 and this one to the power 1. So the powers are in the ratio of 2 to 1. And the equation is in the form ax squared plus bx plus c equal to 0. We can also see in this case that a equals 1, b equals 5, and c equals 6.
Oh, I see what you mean.
If you would like to try this for yourself, here are some questions just for you.
Okay, now that we know it's a quadratic equation, how do we solve it?
Well, in this case, the first step has already been done for us. The first step in solving a quadratic equation is to write the equation in the form ax squared plus or minus bx plus or minus c equal to 0.
Aren't they always in that form?
Not always. Sometimes we first need to simplify the equation, like in these two examples here. In the second question, in order to get it into the right form, we would first need to get rid of the fractions. In question 3, we would need to get rid of the brackets. Do you think you could do that?
Yes, I think I can, or at least I'll give it a try.
That's the spirit.
In this one that has fractions, I think we need to start by putting everything over a lowest common denominator.
Spot on, Teboho. Keep going.
The LCM here would be b plus 2 times b plus 1. Which means I have to multiply this term by b plus 1, this one by b plus 2, b plus 1, and this last one by b plus 2.
So far so good, Teboho. Before you carry on though, I want us to quickly look at the denominator. When we have an unknown in the denominator, as we do here, we need to be careful with our answers. Remember that we cannot have 0 in the denominator. In other words, we have a restriction. In this case, b cannot equal -2 or -1, since both of these would give us 0 in the denominator.
I'll have to remember that when we're working out our values for b at the end of the calculation. Now, we can do anything to an equation as long as we do it to both sides. So, if I multiply both sides by the denominators will cancel out, leaving me with the numerators on both sides. All I need to do now is multiply out the brackets. Then, I move everything to one side and collect like terms. And there we are. It's in the form of ax squared plus bx minus c equal to 0.
That's excellent, Deboho. But can I ask you something? Do you think your answer is in its simplest form?
Well, I suppose we could take out a common factor of 2 to make the equation simpler.
That was very well done, Deboho. Sometimes an equation might not look like a quadratic at first glance. We need to first simplify it by getting rid of fractions and/or brackets before we can tell whether it's quadratic or not. Do you think you could do this too? Why not give it a try? Now that we have the equation in the right form, we can move on to the next step. But before we do, let me ask you something. I want us to consider this equation. A times b equals 0. We need to find the values of a and b that make this statement true. What do we get when we multiply a by 0?
0.
And if I multiply 0 by b?
0.
So if a multiplied by b was equal to 0, what would we be able to say about the values of a and b?
Well, one of them will have to be equal to 0. So either a must equal 0 or b must equal 0.
Right. If we extend that logic further, we could say that if we had any two factors multiplied together and equal to 0, either one of those factors could be equal to 0.
Yes, that's right.
Now, let's have a look at the equation from question 2 again. The equation is equal to 0, so if we could somehow make this side a product of two factors, we would be able to say that either one of those factors could be equal to 0. We've already learned the techniques of writing an expression as a product of its factors.
Hold on, I think I see where you're going with this one. You're saying that if we could factorize this side, we would be able to say that each of the factors could be equal to 0.
That's absolutely right, Deboho. What we need to do is factorize the trinomial. Do you remember how to do that?
I remember factorizing trinomials in class, but to be completely honest, I could never quite master it.
All right, we'll quickly go over it again. If you look at the equation carefully, you'll see that the equation itself gives you instructions on how to find the factors. Almost like a secret maths code.
A maths code? I've never heard about that before. Are you sure?
Yes, I'm sure. Here, let me show you. Have a look at these equations. What do you notice about them?
They all look very similar. Only the signs are different. Does that mean the answers will be similar too?
Good question. Let me cheat a little bit here and show you what these two equations would look like when they've been factorized.
That isn't at all what I expected. Even though the equations are very similar, the factors are different.
And why do you think they have different solutions?
Well, the only difference between the equations are these signs here, so that must have something to do with it. I'm just not sure how it makes a difference though.
All right, let's have a look then. We'll use a generic example using placeholders for the variables for now. Do you agree that if we multiply the brackets out and collected like terms, it would give us a quadratic equation in standard form?
Yes, that's right.
All right, let me do that. Let's compare this with one of the equations we were given. Can you see that in order to factorize the equation, we use the factors of the first term and the factors of the last term? And when we multiply out and collect like terms, the combination of these will give us the middle term.
I see what you mean. The first term is y squared, and in the brackets we have a y here and a y here. Y times y is y squared, so these are the factors of y squared. The last term is SV, and we have an S in this bracket and a V in this bracket, because they are the factors of SV.
Good, Deboho. So we are saying that in order to factorize a trinomial, we need to know the factors of the first and the last terms. Now, let's go back to the examples we've been working with. In this equation, the first term is 1y squared. So its factors are 1y and 1y. The last term is 6, and the factors are 3 and 2. If we then cross multiply, it will give us like terms that make up the middle term. Can you tell me what we would have to do to these like terms to give us the middle term?
We would have to add them together.
Good. Now let's look at the other equation. The factors of the first term are 1y and 1y. We already know that the factors of the last term in this case are 6 and 1. If we cross multiply, we get 6y and 1y. What would we have to do to these like terms in order to find the middle term of 5y?
We would have to subtract them.
Okay, let's look at the sign in front of the last term. What do you notice?
Oh, I get it. The sign of the last term tells us whether we must add or subtract in order to find the middle term.
In other words, if the last term is positive, then the factors are added to get the middle term. This means that both terms must be negative or both terms must be positive. When the last term is negative, we must subtract the factors to get the middle term. This means that the terms will have different signs and the large term will take the sign of the last term. And if we use this clue, it makes it easier for us to work out which factors we need to use in the brackets.
Oh, that's really clever.
It is, isn't it?
I think I know how to do this now. Can I have a go at factorizing the next one?
Sure. Here you go.
I know I need two brackets, so I'll write them down. The factors of the first term are 1y and 1y. The factors of 6 are 3 and 2, or 2 and 3, or 6 and 1, or 1 and 6. Now I see which of these, when I cross multiply and add, will give me 5y. So, that is 3 and 2. If I put this into brackets, I get... Now all I need to do is put in the signs. How do I know which signs to put in the brackets?
Let's see if you can work it out for yourself. Have a look at the original trinomial again. What is the sign in front of the middle term?
It's a minus sign. Oh, I see it. These two terms collected should give me negative 5y, not positive 5y. So, this needs to be minus 3y and minus 2y in order to give me minus 5y. I see another clue here was that the last term had a plus sign. So, the two brackets will both be either plus plus or minus minus. In this case, they must add up to minus 5, so minus minus.
Well spotted, Debuho.
So there is a minus in both brackets.
If the sign in front of C is positive, the signs in the brackets will be the same, and they will be the sign in front of the B term. If the sign in front of the C is negative, the signs in the brackets will be different, and the larger number will take the sign of the B term.
That will make things a lot easier.
Do you think you're ready to try a slightly harder question?
Yeah, I think I'm up for a challenge.
Why don't you try this next question on your worksheet?
All right, here goes.
To start off with, I need to make sure it's in the simplest standard form so that I can factorize it more easily. Now, I need the factors of the first and the last terms. The factors of the first term are 2x and 1x. The factors of the last term are... Now we need to cross multiply till we find the factors which subtract to give us 5x. So that is 3 and 4. Let me put that into the brackets. The sign of C is negative, so the signs in the brackets are different. And the bigger number takes the sign of B, which means there is a minus here in this bracket and a plus here in this bracket.
Excellent, Devoho. You've really got the hang of factorizing now.
Yes, I do. Well, it does really take a long time to factorize when there's so many factors.
Actually, there is another method which is much shorter, but before we look at that, we need to finish off the question we are busy with.
What do you mean finish off?
Well, the question asks us to solve for the unknown. What we have done so far is factorize the equation so that we can let each bracket equal 0 in order to find the unknown. In other words, we haven't answered the question yet.
Ah, yes, I see what you mean. Let me do that quickly. To solve for x, I let each bracket equal 0, because if the terms are multiplied and are equal to 0, either term could be equal to 0. Now I can move everything to the other side until I've isolated the unknown.
So, x equals -1.5, or x equals 4.
That was a really long equation. Do all quadratic equations take this long to solve?
Well, the mechanics of calculations are always the same, but the more practice you get, the quicker they are to solve. Oh, look at the time. It's getting quite late. You'd better get going or you're going to miss your transport. We can carry on with this tomorrow afternoon. Here are some practice examples for you to try on your own.